In this video, we're going to go over balancing chemical equations with a little bit of a quiz. First, let's talk about chemical reactions. When we have chemical reactions, we must abide by this rule called the conservation of matter. In any chemical reaction, we cannot create or destroy atoms. So for instance, if we're going to take these two sodium atoms, these two Na atoms, and combine them with two Cl atoms to make NaCl, we can't have a situation where we only end up with one of these NaCl molecules. You'll see we start with two Nas and two Cls, so we must end with two Nas and two Cls. To make this equation work, we'll need another NaCl atom. Now those atoms on both sides are equal, and that is the conservation of matter. When it comes to chemical reactions in general, though, we have to set up our chemical reaction in the same way. First, we'll put our starting materials, also called our reactants, on the left side. We'll then put an arrow in the middle that faces towards the right. And we'll put our ending materials, our products, or what we create, on the right side. So every chemical reaction will show what we start with on the left, then an arrow showing what they eventually create. Because in chemistry, we have starting materials and we create something new. That is the definition of a chemical reaction for us. But to make this conservation of matter work, we need to make sure we first count the amount of atoms on both sides of a reaction. So whenever we perform that reaction, we're going to first count those atoms, and we're going to assume that no number next to an element means there is one of that element. For instance, the reaction I showed before, Na plus Cl2 creates NaCl. First, I'll set up a line down from that arrow, separating us from the reactants and the products. I'll then put spaces where I can count my amount of atoms, and I'll arrange it in the same order, NaCl on the left, NaCl on the right. I then write in my ones next to any element that doesn't have a number already. You don't have to do this step, but it makes it a little easier. And now I'll count my number of atoms. Na on the reactant side as 1, Cl on the reactant side as 2, you can see that right here. Na on the product side as 1, and Cl on the product side as 1 as well. Now we can see there's an issue here. There's more Cl's on the left than there are on the right, but we will take care of this in a later step. One quick note about counting atoms. We want to make sure we count all of the atoms on a side. For instance, in this reaction, if we do the exact same thing we did on the previous slide, put in ones for any element that doesn't have a number, draw a line down from our arrow, and then arrange our elements in the same order, MgHO. We have one Mg here, two H's, and one O. On the right, we have again MgHO, the same order. We can see we have one Mg. I'm going to skip ahead and say that we have one O atom. Notice that we have one H from this molecule and two H's over here. So in total, one H plus two H's gives us a total of 3. So we need to count all of the atoms on a side. Now it's your turn to try. First things first, which elements are which chemicals are the reactants in the equation above? You can select up to 2 answers. There may be as much as 2 correct answers. Next, how many Al atoms are on the left side? You should have answered that the reactants are Al and Fe2O3. And you should have answered that there is one Al atom on the left side because no number means 1. Next, how many O atoms are on the right side? Go ahead and answer that question. There are 3 O atoms on the right side of this equation, on the product side. Let's try one more example. Where are the products in this equation above? Again, you can select up to 2 chemicals. You should have answered that CO2 and H2O are our products because they are on the right side of that arrow. Next, how many H atoms are on the left side? This one should have been pretty easy. There's only 2 H atoms on the left side. And next, how many O atoms are on the right side? Check your answer. There's 2 O atoms here and 1 O atom here. So in total, 2 plus 1 gives us 3. All right, let's move on to balancing our chemical equations. So how do we balance our chemical reactions or equations? Well, we can't change atoms directly in a reaction because that would change the chemicals themselves. Instead, we need to change the amount of the molecules we're dealing with. First, I'll get us right back to where we started in one of our previous slides with our counted amount of atoms, 1 Na and 2 Cls on the left, 1 Na and 1 Cl on the right. And now I need to get more Cl atoms on the right side. You can see that it's unbalanced. We have 2 on the left and 1 on the right. We need more over here. So I need to put a number in front that tells us how many groups of 1 Cl I'll need. If I put a 2 in front of here, they would give us 2 times 1 Cl. But it also gives us 2 times 1 Na. So 2 times 1 Cl updates our Cl count to 2. And 2 times 1 Na updates our Na count to 2. Notice that our Cls are now balanced, but now we need to balance our Na on the left side as well. When we change that amount of NaCl molecules over here, every atom in that molecule changed. Let's go ahead and fix our problem. What number in front of Na times 1 balances us? Well, 2 times 1 gives us 2 Na atoms. And now we're balanced. We have the same amount of Na atoms on both sides, and we have the same amount of Cl atoms on both sides. Now it's your turn. Go ahead and try to balance the equation above on a separate sheet of paper or a whiteboard, and then answer the following questions. First, what number should go in front of the Mg? What big number should go in front of the Mg to balance? Next, what number should go in front of the MgO to balance this equation? Check your answers. Your balanced equation should have looked like this. Pause the video if you need to. Let's try a second example. This one's a little bit tougher. Now we have 4 different elements. But do the same thing on a separate sheet of paper or a whiteboard. Balance this equation and then answer the following questions. First, what big number should go in front of the NaCl? And second, what big number should go in front of the CaCl2 over here in the product side? Check your answers and your work based on the balanced equation on screen. Pause the video if you need to. We have one more example. Try to balance this equation. This one is especially difficult. Balance the equation on a separate sheet of paper or a whiteboard and answer the following questions. First, what number should go in front of CO2? What big number will end up in front of CO2? And next, what big number should end up in front of O2? What number will balance the equation when it's in front of O2? Check your work and your answers based on what's on screen and pause the video if you need to. And that is the Unit 3, Section 1 EdPuzzle quiz on balancing chemical equations.